Regular physical activity remains one of the most effective and universally accessible interventions for extending health span and delaying the onset of age-related diseases. While the benefits of exercise for cardiovascular and metabolic health are well known, research increasingly highlights how movement exerts its influence at the cellular and molecular level, enhancing mitochondrial function, reducing oxidative stress, supporting protein homeostasis, and preserving physiological resilience well into old age. Both aerobic and resistance training appear to modulate aging pathways in ways that closely align with the biological profiles observed in centenarians and other exceptionally long-lived individuals. One of the most profound cellular effects of physical activity is the stimulation of mitochondrial biogenesis, the process by which new mitochondria are formed within cells. Mitochondria serve as the energy powerhouses of cells, and their efficiency tends to decline with age, leading to reduced ADP production and increased oxidative damage. Exercise, particularly endurance and aerobic activities, upregulates key regulators of mitochondrial biogenesis such as PGC, 1A, peroxisome proliferator activated receptor gamma coactivator 1-alpha, MPK, and SIRT1. These signaling molecules coordinate the transcription of mitochondrial DNA and the assembly of respiratory chain complexes, restoring mitochondrial density and function. In older adults, exercise-induced improvements in mitochondrial quality help sustain energy metabolism, muscle strength, and brain health, all of which contribute to functional independence. In tandem with improved mitochondrial capacity, exercise plays a pivotal role in mitigating oxidative stress, a central mechanism of aging. While physical activity generates reactive oxygen species, ROS, acutely, it also triggers a hormetic response that strengthens the body's antioxidant defenses. Over time, this adaptive process results in lower basal levels of oxidative damage to lipids, proteins, and DNA. Enhanced activity of enzymes such as superoxide dismutase, SOD, glutathione peroxidase, and catalase has been observed in physically active older adults, contributing to reduced inflammation and improved redox homeostasis. This antioxidant adaptation is particularly important in tissues vulnerable to oxidative injury, including the brain, heart, and skeletal muscle. From a cardiovascular perspective, exercise induces a wide array of protective changes. It improves endothelial function, promotes arterial elasticity, and lowers blood pressure, all of which reduce the risk of atherosclerosis and vascular aging. Exercise increases nitric oxide (NO) availability, supporting vasodilation and enhancing tissue perfusion. These effects are not merely functional but structural. Regular aerobic activity preserves capillary density in muscle and brain tissue, ensuring oxygen and nutrient delivery even as global circulation declines with age. Longitudinal studies show that active older adults maintain better cardiovascular performance, lower resting heart rates, and slower arterial stiffening, all markers associated with reduced mortality and morbidity. Resistance training, though sometimes overlooked in discussions of longevity, is equally vital for sustaining health in later life. It counteracts sarcopenia, the age-related loss of muscle mass and strength, by stimulating muscle protein synthesis and enhancing neuromuscular coordination. Strength training also influences metabolic health by improving insulin sensitivity and glucose uptake, especially in skeletal muscle, the body's largest site of glucose disposal. These benefits lower the risk of type 2 diabetes and metabolic syndrome, two major accelerants of biological aging. In addition, resistance exercise has been shown to increase levels of myokines, such as irisin and IL-15, which exert anti-inflammatory and neuroprotective effects. Both aerobic and resistance training exert a profound influence on systemic inflammation, often attenuating the chronic low-grade inflammation that characterizes aging. Regular exercise lowers circulating levels of C-reactive protein, CRP, interleukin-6, IL-6, and tumor necrosis factor alpha, TNFA, while enhancing anti-inflammatory mediators. This modulation of the immune system contributes to reduced incidence of chronic diseases and may slow immune senescence, preserving the capacity to respond to infections and vaccines. Importantly, the benefits of exercise persist even when started later in life. Studies involving previously sedentary older adults show that as little as 150 minutes per week of moderate aerobic activity, alongside twice-weekly strength training, can significantly improve physical function, metabolic markers, and subjective well-being. In advanced age, regular movement also supports balance, coordination, and mobility, helping to prevent falls and the cascade of frailty that often follows. Cellular aging is a complex, multifactorial process, but movement appears to exert a unifying and restorative influence across biological systems. From enhancing mitochondrial function and antioxidant capacity to preserving vascular health and musculoskeletal integrity, exercise remains one of the most powerful tools for extending both lifespan and health span. It is not merely about burning calories or maintaining weight. It is about rewiring aging itself, slowing its pace, blunting its damage, and preserving vitality through a lifelong dialogue between muscle and molecule. As centenarians and healthy older adults consistently demonstrate, the body's capacity for renewal does not vanish with age. It simply awaits the right signals, many of which begin with movement.